Hello friends, my name is Shivam from DevOps Schools and I will help you to enable your learning process in various technologies of DevOps, artificial intelligence, machine learning, big data and many more. This is our initiative to help you by sharing multiple tutorials and videos. And if you want any specific tutorials on any particular topic, then please do comment in the below comment section and I will help you with it. Also, please subscribe to our premium services on YouTube, which will give you access to more content and videos to enhance your knowledge about all these topics. Also, if you want me to help you with regards to the online trainings and classroom sessions by our qualified trainers, then please do write me at contact@devopsschool.com. Thank you.
Okay, so now I'm going to talk about the services. Now question is, what is services? So guys, in Kubernetes, whenever we talk about the services, simply tell to your mind and say, you inform it to your mind like services in Kubernetes is nothing but load balancer. Yeah, load balancer. But load balancer for what? Load balancer for pod. Yes, load balancer for pod. So guys, if I look at it, load balancer world, okay, you all understand that how load balancer works. Remember, for the load balancer to work, conditions, IP address need to be reachable, then different IP address has to be there and same port has to be there. Okay, these are the few conditions to work with load balancer, generic one. Now algorithm and all, whether it's a random load balancing or some other algorithm which get applied, depends on the geography, depends on the many other things. That's I'm not complicating right now. Okay, so basically there are two types of load balancer which we have worked. I have worked with it. One is like a network load balancer, which load balance the on a network. Okay, and another one is application load balancer. In AWS also we have a network load balancer and application load balancer. But in the Kubernetes, how can we set up a load balancer? Mind it here, when we use a cloud services like AWS, so you create a load balancer, but for what? So virtual machines, you create a load balancer for VMs. So here when we create a load balancer, for what? For pod. Yeah, for pod. In this session, we will create a load balancer for pod. So now the question is, okay, fine, no network load balancer, application load balancer, but for the pod, balancing the pod. Okay, why? But how can we do that? Which is the API resources for we have for that? Which API resources will work for the network load balancer? Which API resources will work for the application load balancer? So guys, then when I talk about this network load balancer, then here I say services. Yeah, the same topic which I'm teaching you. When you say application load balancer, then here we have a ingresses. Okay, so now I'm teaching you services right now, but ingresses, if you want to learn, you can come to DevOpsSchool.com. Multiple videos are there and tutorials, you can check it out. Okay, so guys, what we are talking about is load balancer, network load balancer services. Is that clear for everyone? The context? All of you? Am I audible?
Yeah.
So guys, let's trace it back. This is me, okay? And I am in my home with my laptop. In my laptop, I have a browser. In the browser, I type www.devopsSchool.com. The moment I type, browser go travel to the internet and reach out to the nearest DNS server, whatever it is having, right? DNS server. From the DNS server, it says, okay, DevOpsSchool.com is mapped to one of the IP address, which is called this one. Now the question is, what is this? What is this? So this IP address, do you think this is where the DevOps school is running?
No, it's a
No.
virtual IP.
No, it's not a virtual IP. This IP address, it would be a IP address of network load balancer or application load balancer. Okay, network load balancer or application load balancer. From there, this application, because it's a load balancer, it has to balance something, right? It has to balance something. So what balance? So earlier we were working with the physical machine, then virtual machines, but now pod. So in a cluster, you are having multiple Apache pod. 1, 2, 3, 4, 5, 6. Now this IP address, which is a load balancer, will balance all this pod and can send the communication to one of the pod, let's say this pod. So this is the app server. Oh, sorry, web server. Okay, this is the web server. Let's say Apache. Apache will redirect the code to somewhere else, right? That's called app server. App server also having multiple pod, guys. 1, 20, 30, 50, 100. So this also need to be load balance, right? All this need to be load balance. So how to load balance? So here we also need one load balancer. Okay, think about it. Here we need one load balancer. Here we need load balancer. Now from here, the traffic will come to here, and then probably it will travel to here. And from there, again one load balancer, and after that database. So this is a typical, I'm not saying all the project is based on same architecture. Something generic which we want to discuss. This is something which happens. Are you understanding it now? Guys?
Yes, Rajesh.
But guys, there is a problem, big problem. Remember, this load balancer cannot reach to the pod directly. That's the problem. See, the pod is accessible within what? Within what?
Namespace.
Namespace.
No. I said pod accessibility. I'm not talking where you can run the pod. I said pod is accessible. That means IP address of the pod.
Cluster.
Remember, I was
Cluster.
running in the cluster only. Remember, the pod is accessible only within the cluster, but this load balancer is external, exposed to the whole world. So this load balancer from there, you cannot reach to the pod. Did you understand the problem here? All of you?
Yes.
So if you have understood the problem, then we will find a solution. Remember how the load balancer will work. IP address need to be reachable. Different IP address, same port. But here, forget about the second and third condition. First condition itself not. You cannot reach out from here. So guys, if you have this problem in mind, the solution is services. So now services is a network load balancer, but how it works, what exactly this is, and all we'll learn now. So guys, look at it. First, forget about the outside of communication. I'm not talking about the outside. Think about inside a cluster. Let's say you have a one deployment of front end. One deployment will have a 5 pod, 10 pod, 2000 pod. It can be any number of pod. Think about it. So you have a one deployment of front end and one deployment of back end. So now front end need to talk to back end, correct? But how many pod you have? Not one. You have a 10, 20 pod you have. So guys, here if you just look at this image, here in your cluster you have a 6 node. Node 1, 2, 3, 4, 5, 6. If you look at it very carefully, each node you have a pod. If you look at the pod also, some pods are front end pod, some pods are database pod. You know, as per the non-affinity, it can scheduler can create anywhere. We also see that each pod got IP address. We also observe that the pod is gone, so IP address will not be retained. You get a new pod with a new IP address. So here, this is how you have a two deployment, front end and database. So guys, did you understand that so far? This image? All of you? Guys, are you there? Please keep responding it.
Yeah, yes.
Okay. So now you see that here, the problem here is, now the problem within a cluster, I'm not talking about the outside of the cluster. I'm only solving the problem inside the cluster. The problem here is which front end pod will talk to which back end. How can you hard code that? Because IP address will keep changing. Think about it. So the front end one will go to the back end one or two. Front end two will go to the back end one and two or something like that. It will keep happening. So how do you know which container, which pod from the front end will talk to which container or which pod of the back end? There's a chaos, right? One by one, there's no, it's like one pod like that. There are thousands of pod of the front end, thousands of pod you may have a back end. One more thing you remember, the pod get deleted, new get created, new IP address you get added. So how do you solve this problem? Any idea how do you solve the problem? Anyone? So now guys, next problem what we have is, here we have a front end pod. Now you want to direct, and there's a two deployment in the database also, version 1 deployment, version 2 deployment. Now how do you control whether you want to deploy from the front end to the database 1 v1 or database 2? How do you do that? This kind of problem. That is where the guys solution is coming. This is called service. What is service? Service is a network load balancer managed service in Kubernetes. So what do you do? You work with a service. So here what happens, all the pod of front end, you embed the IP address of your service. Here the service, the named with a dv dot something, an IP address, is balancing the two pod here, the below one. So right now when you hit this service, which is a network load balancer, it will redirect to either pod 1 or pod 2. So this is the way within a cluster. I'm saying, stating, look at this. Within a cluster, if you want the 2 services or 20 services, 2000 services, so you create a service. Service will represent your applications. So now guys, I said one statement day for yesterday, and I said that the Kubernetes is an orchestrator for microservices. Do you remember that? Do you remember the scenario? How do you manage the multiple services? Microservices.
Yeah.
So guys, here in that case, what you do, you may have 100 microservices, so you will have 100 deployment, simple. And guys, for each deployment you create one service, and this service will be managed by Kubernetes, not by you. See that, and it's a free of cost. It's a free of cost. So guys, this is the beauty about service. Service is your load balancer for the pod. Okay, so now you see here, suddenly you did the scaling up, you did very well in the demo also and lab also. So it's become 2 to 4. Maybe you have 100 pod, it'll become a 200. You know that new IP address keep coming, new pods keep adding. So how this service will register those new pod? How? New pod, you have got it with the new IP address. How these pods will get registered automatically load balanced by the service? That's one problem. Let's say second problem. You have a deployment, but you want to deploy the version 1. You want to create a service for the version 1 or version 2, not everything. You don't want this mess up. Like sometime that if your end user will request, he will get Gmail. Sometime he'll get a Gmail with a 50 email ID, and sometime he'll log in, then he'll get a 100 email ID. Old database, new database. So it should not be like that, right? So for that, what to do? How to fix that? How to automatically register the new pod? How to automatically deregister the gone pod? How to align those pod as per their releases? How can we solve that problem? So that is where the label rocks. Yes, label rocks. So service can load balance the pod, but I am talking about how the new pod will get automatically added, how the gone pod will get automatically deleted, how this you can play, like you can redirect all the communication to the version 1 rather than version 2. How can you do that? Answer is label rocks. Now the question is, what is label? So guys, I don't know how many of you have seen the label. Anyone have seen the label with the pod, deployment, replication controller, and so on?
Yeah, Rajesh.
Yeah. So guys, I'm talking about the same label. Let me tell you here, guys, name is unique. Name is unique. But any resources, I repeat, any resources in the Kubernetes, you can label it as many times. For example, my name is Rajesh, which is a fixed one. You cannot change this. But you can call me trainer. You can call me Docker guys. You can call me DevOps guys. Multiple labels you can give it to me. Still, I will represent the same person. So same way. So any resources which you create here, service, pod, or anything else, but here when I'm talking about the service, I just need a pod and service label. So here what is happening, hear me out very clearly, the statement. The moment the labels of pod matches with the labels of service, okay, the moment the labels of pod is matching with the labels of service, the service only will load balance those pods. Simple. Service will only load balance those pod which is matched, and that's all. And there's a one asterisk sign I'm adding here. Why asterisk sign? Because something which is hidden, which I'm not talking right now, that is related to selector. So right now I'll skip the discussion. During the demo I'll show you. Okay, so here what is happening, how this pod will load balance the service, how the service will load balance the pod. Simple. Labels of pod must match with the labels of service, and if it is matching, the service will only load balance those pod. So here what is happening in this scenario, you have a 3 pod and the pod labeled with B, prod B 1.3, prod B 1.3, prod B 1.3. So in that case, the service is load balancing the 3 pod. Simple. Why? Because the service label and pods label is matching. So here pods label must match with the service label. The automatically service will start load balancing those pod. So when you hit the service, either you get the pod 1, 2, or 3. So now you tell me, guys, based on your understanding so far, tell me this labeling, which is we have done it. So that labeling is correctly done or not done? Tell me. Labeling is done correctly or not? All of you?
There are three different labels.
No, that's okay. Three different labels, but it's matching with the service. But I'm saying this, this labeling is done by us, whether we did the right labeling or not.
We labeled everything as same, so we won't be able to differentiate.
There is everything is backend.
No. Okay, again, I'm repeating my statement. The question was how this pod will be load balanced by the service. What is the rule for it? How? So rule states the moment the label of pods matches with the labels of service, those pod will be load balanced by the service. Simple. So my question again, follow-up question was, who's doing the labeling? Human, we, you, me. But the question is, did we did the load labeling correctly or not?
No, here actually DB and auth both have the
No,
same.
here the IP address is same. Two pods have same IP address, so it's not correct.
So here, guys, this labeling is not correct. Why? What is the mistake we have done in this case? You know, the labels of auth, the pod of auth and pod of DB, both we labeled the same thing. That means what is happening? You know, sometimes the service redirect the traffic to the database, that's expected, but the next moment service redirect the database, traffic to the authorization login page. This is not good, right? Sometime you log into the Gmail and you see registration page, or sometime you log into the Gmail and you see your Gmail box. Which one it's not good, right? So what I'm trying to say to all of you, how it works, the moment the labels of pod matches with the labels of service, those pod will be load balanced by the service. But who's labeling it? You, me. I should be very careful while labeling it. Okay, are you understanding my point here? All of you?
So Rajesh, I have a little bit confusion. What is the right view then? So if you say that this labeling is wrong,
should have not labeled the prod B1.3 to auth. Simple. Because you are added the wrong pod to the service load balancer. No. Simple. Should have not done it. Got it?
And Rajesh, one more question. So does this rule apply within a namespace or across namespace?
No, the service scope is namespace. Very good question. But the service scope of the service is, let me tell you here in simple way. You can access the, you can create the service within a namespace. But the service, whatever the IP address you get it, you can access within a cluster. I'll talk about that. Okay, within a cluster.
So Rajesh, one more question. Like you said, the service itself is managed, right? Who manages it in the master? Like there should be somebody.
Kubernetes.
Which part of control plane or?
No. For that you have to deep dive into the little bit of more networking. Service is basically it's like it's not something like a server if you are imagining, oh, it'll be server, some applications or something. This service is inbuilt capabilities what we have in the Kubernetes, and this service is basically at the routing combination of IP tables and routing tables, which is done at the kubeproxy level. So
okay.
So that's not something, some software. It's not Nginx or something like that.
Okay.
Okay, guys. So look at this here.
Rajesh, one question. So as we know that load balancing on the same pods with the labeling we are doing. And if, say, for example, accidentally I picked up auth instead of DB, won't the intelligence should not be there to reflect the error, because the logic is there, right? Expectation is that it should be all same set of pods. So anything which is differently coming, I know, like you said, we should manage on our own, but accidentally if I add, then shouldn't that reflect?
This I said just to understand the importance of label. Okay, I said, but when you work with the deployments and all, remember, let's say this is your application and you run the deployment. So deployment create a consistent label for all the pod, not one pod or something. Okay, so here I'm trying to help you to understand how service work. But when you create a deployment and expose the deployments all the pod to the service, then the deployment will control the label has to be matched as per the deployment specification. So those are the control is there. So manually you will set the label for the deployment, not for the each pod, because whatever you set for the deployment spec, it will be implemented in the pods. That's how it is.
Rajesh, I'm having a design question. In this slide, there are 4 DBs. Means 4 pod which is containing same DB container, right?
Mm-hmm.
So suppose one user logged in and that information got stored in container of first pod. So if he logged in again, so how service will know that it should go to container 1?
No. I'm talking about the static discussion is load balancing. I'm not talking about the database. Remember here I said that answer. First you come to the web server, then from the app server, from there it database, and database pods to database directory. So this is handled a little bit separately and different way. So just to answer your question, let's say if you look at this database, tell me the component of database. Tell me the component of database.
Database, then table.
No. Component of database means
MDF and
see.
LDFs.
Okay. Probably I confused you all with my question. So see here what happens. This is the web server. So many. Think about it. This is the app server. Now this will be load balancer. Here you need a load balancer. Now this is a web. This is app. Now database also divided into 2 part. One we call it engine. Okay, and engine I'm saying N, and another one which call it data directory. Okay, so data directory. So see how these communications will flow. So first you load balancer here, this travel this pod or whatever it is, this will connect to this redirected to this pod. Now this will redirect it to one of the engine, database engine. Engine is applications, okay, data like MySQL engine, Oracle engine, and here. Now but here this all the engine will have only one data directory, and this data directory will be shared with all the engines. Okay, so that is how you can do that. So here I'm still at this level. Not got into this part. Are you able to understand this?
Yes, yeah.
So storage is not covered so far, so you'll have to wait for it. I'm still creating a load balancer, but for balancing what? Pod. Got it? And this is the static content. This is the application static content. This is engine is also a static content. Only the things which is here data directory, which is a dynamic content. For dynamic content, I have a different resources. We have a different resources. Make sense?
Yeah.
To watch our complete session, enroll for our premium membership. Click onto the join button and enroll yourself with the best suited option.
So here, if you look at this, guys, I have a service labeled with the prod and B. So the moment you modify something like this, then what will happen? The multiple other pods will also get load balance. Here you see, I just modify prod B, prod B, prod B. So all the pods which is matches with the prod B, prod B, prod B, it get load balance. So sometime again that your service is coming to 1.4 or sometime 1.3. So how to fix this problem? Simple. Add one more tag in the service 1.4, and now you see that load balancing will happen only for the service. So now the question is, what is a service? So guys, service has an inbuilt property to send the traffic only to the healthy pod, okay, running pod, not non-healthy pod. Now guys, it can be configured for session affinities also, and this service can help you to point the things outside of the cluster also. How? That is we have to discuss. And if you ask me what is the logic, what is the algorithm which is applied on the service, it's a random load balancing. And now how this works is network load balancing. I told you uses a TCP by default. This means network pod IP address and port number, IP address and port number of the pod it uses. Okay, so guys, this is your service. Did you understand that what is a service and why do we need it, all of you?
Yeah.
So guys, again I'm recapping the stuff. Please take this in a very straightforward manner. If you want to, you have so many pods for the each deployment, but how this each pod will talk to each other within a cluster, I'm saying application deployment, web deployment, database deployment, but each deployment you have a 20, 30, 50, 100 pods. So how do these will talk to each other? So for that we have a network network load balancing based on the for the pod. So that using that you can load balance the pod within a cluster. But the question is how this pod get how this pod get attached to the service automatically. So the answer is, if the pods label and service label matches, then those pods which is matched with the service label get attached automatically to the service. Now this automatically means someone is there in the cluster which inform all this stuff. That is called core DNS. Okay, you might have seen this pod somewhere. So core DNS is doing all of this stuff. Okay, so with that guys, now I'm going to show you the demo. Okay, so let me show you the demo. Before that, little bit of more things are pending, and so this is the one. So I'm just copying it in order to avoid the writing too much. So it's guys very important. Now service itself, there are types. Service itself, there are types. So here you have a service type which is a cluster IP, node port, load balancer, and external IP. So what is this? So for understanding this, we have to open up and create some diagram. Look at it very carefully guys, all of you. This is your cluster. Okay, and in the cluster you have a two node, one worker node, second worker node. Okay, remember worker node you have a IP address here. This is a physical IP address, remember. Now what you are having, you have one deployment, front end deployment, and one pod, two pod you got it from the front end. You got created one here and one here. There's one more deployment, we have a backend. One pod got created here and one pod got created here. Mind it here, each pod 2 have IP address. This is a pod IP address. Okay, because of Q proxy, any host can talk to any pod can talk to any host within a cluster across. You know that we have discussed so many times. Now the guys here, front end need to talk to backend, but here are two front end, two backend. So which the front end will talk to which backend? So guys, we need one load balancer. This we created a service here. Okay, so here we created a service. This service got created. Remember, this service is inside a cluster only. Okay, so this service is inside a cluster only. So this service will load balance these two pod. So now if you want to reach out to the one of the backend, so this front end you can hard code this pod, this one, what do you say, IP address of it. So did you see that how this setup is done within a cluster? All of you? Guys?
Yes.
So how
So
front
now,
will talk to backend?
what is that?
How the front end will talk to backend? That what I didn't get.
So you can embed this IP address, no? This service also has IP address, no? So front end you will tell this IP address, and when the traffic will reaches here, this will decide here to go or here to go. Correct? Random load balancing. Got it?
Random.
Where is this service?
Okay.
Guys, are you getting it or not?
Yes, Rajesh. So where is this service running?
Service is that's what
Within the
inside a
cluster.
cluster is at the port proxy level. Every proxy get updated with this service. I'm saying it's not an application. I know that what you're thinking. Where is that? We have never discussed about that. I'm telling you, it's a routing rules. So it's at the proxy level. Every host will have a proxy. It's a routing rules. Again, if you have a little bit of no idea about the IP table routing rules and concept of kernel IP tables and all stuff like that, you can read offline. But it's not application. It's a proxy table. Make sense?
Okay. Okay.
So guys, now next question is this service, whatever I created, this service within a cluster, this service we call it a clustered IP service. That's all. The same service which I created within a cluster, this service we call it a cluster IP service. So guys, what is a cluster IP service? The service would load balance the pod. Yeah, C is load balancing the pod. And scope of this service, whatever you create, is a cluster only. That means you cannot access this IP address from outside. You cannot access. Outside you cannot access. No. But within a cluster itself, you can access it. Okay. So guys, did you understand all of you? So far, clustered IP. Now guys, there's a problem. So I want to think simple. I am outside, my client is outside. They want to access one of the front end pod here. One of these, not two, all, one at a time. So what do we do in this case? So guys, I cannot read out the directly pod. I'm outside. Remember, I'm outside of the data center. So how can we do that? So guys, remember, do you remember the port forwarding concept, guys?
Yeah, hit the node port.
So do you remember that port forwarding? I don't know how many of you are listening me at the time. I ask you, please read it whether you understand or not. So port forwarding, you can do the pod deployment and services also, right?
Yeah.
You remember?
Right.
Okay. If you forgot, okay, no problem. I'll show you this.
I'm using minus P option.
Yeah. See here, you can port forward the pod also, service also, deployment also. Now you know that, so now it's very easy to draw. So what happens? I need to create one more service. This is the cluster IP service only. This service only, cluster IP. Okay. So this service I will create. Now this service will load balance these two pod, front end pod. So I got the two service. See, one for the back end, one for the front end. Now this service, unfortunately, also guys, will not be accessible by this. No, it will not be accessible. You know that, right? Because the service also, the scope is clustered only. I told you, service scope is clustered only. The networking scope is clustered only. So what do we do in this case? So guys, this is where this service, hear me out. This service I will expose at the node port. Remember, You did that, I did that. I don't know whether you did it or not, but I did it. 0.0.0.00, remember?
Yeah.
So guys, I expose this service at the node port. Now, can I access this node? Yes, I can access. I can access. But what will happen if there's a too many users? And if you all hit the single node, it will be problem for that particular node, right? Correct?
Yeah, perfect.
So what we do, what we need. So guys, we need, though we can hit that. So we need one external load balancer. Now this load balancer will balance the node port. Mind it, node port, node port. I'm saying port of the node. Okay. So now we all hit, not to that, we all hit to this load balancer. So see the traffic. Look at my screen very carefully. I will hit to this load balancer, which is external out of the cluster. This load balancer can balance the only node port. So my request go to the node port. Node port knows that. Remember, the node port, each node can reach out to the each pod. Each pod can reach out to the each node within a cluster because of kubeproxy. Remember. So now, if I hit to this one, then they will redirect to the service, front-end service at certain port. Front-end service will redirect to one of the front-end pod. Front-end pod will redirect to the back-end service, and back-end service will redirect to one of the back-end pod. Did you understand that all this flow?
Yeah.
So guys, what is a cluster? What is a node port? So guys, simple definition, please read it. Node port, when you create a service with the node port specification, then what happens? There's one clustered IP service get created, and same service that port forwarded to each node. Each node, I said, each node. Means these services get forwarded to here, both the nodes. This is what it happens with the node port. When two things you can get it together. Got it? What is the node port? All of you?
Yeah.
Now guys, there's one more type which is called load balancer. So guys, load balancer, what happens when you directly choose the services for the load balancer, then what will happen? One clustered IP service will get created like this, and this service will get exposed to the node port. See here, one clustered IP service get created, and the same service get port forwarding to node port. And then what happens? This Kubernetes itself will try to create a load balancer, physical load balancer, that at the what do you say, at the AWS or whatever the cloud you are using. So your Kubernetes will talk to AWS, Azure, or Google Cloud and create a physical load balancer. And then what will happen? The Kubernetes itself knows that which are the nodes you have attached to the cluster. So these nodes, they will add to the physical load balancer. So in this case, in our case, this will be failed because my Kubernetes has no access to AWS. But if you go for this type, then these four things happen. So if you want simple thing, if you want some pod, some service to be accessible within a cluster, use this one. If you want your service to be accessible at the node port of the node, this one. And if you want the services to be accessible, port to be accessible over the load balancer, external load balancer, this one. Please read it one more time, more time, and tell me if you got it or not.
So Rajesh, quick question. So is cluster IP is equal to a VPC or a private network creation, or how do you?
No. Why? Where is the VPC is coming into the picture? VPC is a physical network. No, VPC is like a node network.
Okay.
Right. I'm talking the pod network. Remember, I discussed
Right.
in the architecture discussion. Pod is a different network. Remember, VNet, I installed it.
Calico, Kubernetes, or any of the networks.
Calico, VNet, Flannel, many are there, guys. Many are there. Sometimes I get lost.
So if I give an option as cluster IP, so let's say I create 5 pods and then they belong to this service, then it becomes
Clustered
its
IP
own.
means what? Clustered IP means, I'll tell you in this. Clustered IP means, let's say you have a 3-4 laptop, and
Right.
you are running some application inside a laptop, and
Mhm.
you all 4 laptops is in your home only. So you can reach out to
Mhm.
anyone, right, within your home, but from outside, no. So same way, the pod, you know the concept Q proxy, have explained it. Clustered IP means the IP which is assigned to the pod and accessible inside a cluster across the node. That's called clustered IP.
So it is like a work group, right? Yeah, what you explained. Oh,
This word, no, this one. No.
okay.
Cluster IP
Okay, then I'll
means,
go.
yeah.
Yeah, okay.
More questions, guys? So guys, simple. You create, again, I'm repeating. You remember what, I'll wrap up now this thing. What is service? Service is a network load balancer. Very simple statement. Network load balancer. If those who have no idea about this, please read more about it. Now the question is on what algorithm it works. So this algorithm is random load balancing. Okay, random load balancing. Now the next question is, this is doing the load balance on the IP address and port of the pod. Now how this load balancing added the pod, the service load balancing added to the pod. So the moment you match the labels of the pod and with the service label, it automatically load balance those pod. Asterisk is applied because I will tell you some more information during the lab. Okay, now the question is, when you create the service, the scope of the service is only cluster only. This service also scope is clustered. But what happens, instead of manually doing that, create a service and then port forwarded to the each node, if you directly use the node port, what will happen, there's one service will get created which is a clustered IP service, and that they will port forward to the each node actually, automated way. Why to waste time? Let's say I'll put it in this way. You have a one service you created. Now that service you have to go log into 20 boxes and the port forwarding the 20 boxes, and then you will be able to access. That's not good, right? So rather than they say, if you want that the service to be accessible on the node port, use this type is equal to node port. Simple. So these two things will happen. Now they say, okay, if you want that load balancer external, if you want the Kubernetes to talk to your external services also, like external load balancer like AWS load balancer, Google Cloud and all, then use the type load balancer. In this case, what will happen, this will get created, this will get created, and then finally these two things will happen. Talk to the cloud and create a physical load balancer, and add all the Kubernetes nodes to the physical load balancer. So this is the automated ways to do that. These are the type. Is that clear, all of you?
Along with that, you can access our other tutorials such as Docker, Ansible, Jenkins, Terraform, Splunk, AWS, Azure, and various other DevOps related premium tutorials with our channel membership. If you would have any issues with our channel membership, you can drop an email to us at contact@devopschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. To get our channel membership, click onto the join button, select the $399 plan and grow your skills immensely. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Thanks for watching.